Hi everyone and welcome to you all from openDAQ. We are thrilled to share with you how openDAQ will make test and measurement easier, faster, more efficient and cost-effective. But let me start with introduction. I'm Sonia, the General Manager of Blueberry, the joint venture that began 1 year ago as a groundbreaking collaboration between HBK and Devasoft, two of the leading players in the T&M industry. The whole year we have been programming, developing, testing, working hard to achieve our ambitious goal to standardize the interfaces in the T&M market. But why, would you ask? Well, Jurek Knies, our CEO, and Niels Rödger, Blueberry's CTO, have the answers. They know everything there is to know about openDAQ, a new SDK for the test and measurement industry. They will share their knowledge with us today. So how will we spend the next hour together? Well, first, Jure and Niels will give you insights into openDAQ. We will show you an amazing demo. But we also want to hear from you. So during the presentation, you can pose your questions in the live chat, and Jure and Niels will give answers at the end of session. So let's start our first openDAQ community event for real. Jure, please explain what we have done that can benefit so many in the T&M market.
Also, a warm welcome from my side. It's really great that we are here together after more than a year of hard work. I'm Jurek Knies, founder and president of Devasoft and co-founder and CEO of openDAQ Foundation. Let me explain why we developed the new openDAQ SDK. Looking at the test and measurement market right now, system integrators are forced to integrate almost all the devices from scratch, one by one. You need to find out how the interface of the device is defined, if a device driver of a vendor is available, and then implement it. But imagine that you don't need to do it. Imagine all devices have the same interface, or rather, all interfaces are abstracted into one common API and accessible via a rich software development kit. Okay, great for a simple solution. But as you know, our business is not simple. Our devices are often integrated into complex system topology as shown in the figure. Often beside the data acquisition, you also need to trigger your test case via a controller. Wouldn't it be a dream if there was one SDK to rule them all? And if you can imagine all these things, the SDK is the missing piece. The shareholders are already fully on board, and our future products will support the openDAQ SDK so that you can connect these to your needs. Integrate the devices into your own application and access the devices via Python, C++, and more. System integration is just easy. But what about the devices from other vendors? Both shareholders have put our core code of data handling in the openDAQ SDK, and our best developers are working on it full-time. We actually got a lot of inquiries from other manufacturers of data acquisition instruments to support the SDK. Everyone is welcome, as we really want the SDK to become an industry standard. To fully commit ourselves to this goal, SDK will be available as an open source by the end of this year. This is also why we choose the name openDAQ. Open, to access to as many devices as possible, as simple as possible. Open, for everyone to use. Open, for everyone to contribute. By the end of the year, we are going open source. It is just openDAQ.
Welcome to the openDAQ SDK demo. Visit our website openDAQ.io and click on the Documentations link. In the download sections, you will find all the necessary files to get started, including the SDK installer for Windows, Linux, Python bindings, examples, a device simulator, and all protocol specifications and documentation. To see openDAQ in action, download and run our device simulator VirtualBox image, and then run the Python GUI example application. Click on the Scan Devices button to discover available devices. This will search for all openDAQ compatible devices in your network, including the simulator. Double-click to connect to it. Once connected, you can see all of the device properties, including physical channels, their properties, and available signals. Double-click on Signal to add it to the reference rendering function block, which will show the shape of the signal. You can modify the signal generator properties such as waveform, frequency, and amplitude. For example, we can change the frequency to 1 Hz, and this is immediately reflected on the renderer. You can of course add multiple virtual or real devices and configure and visualize them all together. Our SDK is designed to work on all platforms. We currently provide Windows and Linux packages, but it also runs on macOS and mobile operating systems like Android and iOS. The real purpose of the Blueberry SDK is to program it by yourself. The Getting Started section in our documentation will guide you on how to set up your programming environment. Currently, we provide C++ and Python guides, but we will add other common programming languages like C# and Java in the future. After selecting your programming language, head over to the Application Quick Start Guide. It will show you how to start the simulator and then guide you step by step on how to write your first code in the Blueberry SDK. Guide will show you how to discover devices, how to connect to them, read their signals, and configure their properties. Now, let's see some real examples so that you can see how easy and fast it is. For the sake of readiness, we'll show you the Python code. It always starts by creating the openDAQ instance, which runs the core openDAQ libraries. By simply calling the Available Devices function, you'll get a list of all the devices available in the network, including their names and connection strings. By knowing the device connection string, you can connect to it and display the list of available signals. Reading signal data from devices is easy with our helpers called readers. In example, we will use the basic stream reader to read data from the first signal. Repeating 10 times, we will read 100 samples and print the last sample in the console output. Changing properties is also straightforward. We can list all available properties by calling the function visibleProperties on the first channel. When we know the property name, there is an easy way to read and change its value. In example, we will change the amplitude of the first channel to value 1. With this knowledge, you can configure any setting on the device. On our website, you can also find the API reference that lists and describes all available functions, classes, and more. You can browse or search the guide to find explanations regarding functions and their parameters. All of the shown examples can also be written in C++ with almost the same amount of code. We hope you can see how easy it is to get started and how flexible and scalable the openDAQ SDK is. If you'd like to learn more, please visit us at openDAQ.io.
After this wonderful demonstration of openDAQ, let's summarize the key features. But before that, I will introduce myself. I'm Nils Röttger, the CTO of the joint venture, and I'm responsible for achieving the roadmap and quality goals. Firstly, the SDK is easy to use, since discovery works quickly and easily. Furthermore, through the general approach of self-describing properties, generic user interface can be written. Well-prepared documentation accelerates the familiarization with the SDK. And even better, the SDK is scalable to any numbers of easily configurable openDAQ compliant devices, set up as fast and painless. All this with ultimate performance because the SDK supports the highest possible data rates. This is achieved via multi-threaded design and an efficiency protocols. The question is now, when do we land? When can you get your hands on the openDAQ SDK? We are on the left side of the timeline at the first diamond and are preparing the landing. For this, selected partners get access to the SDK. The reason why only selected partners will get access is that we want to work with the partners in a deep and more focused and intensive way. So this we want to achieve a high quality in our first release. The partners will really put the SDK through its paces. How to become a partner? This will be explained at the end of the presentation, so stay tuned. In addition, from June on, you can ask openDAQ for a reference kit to evaluate the SDK with real hardware. It has analog inputs and outputs, as well as digital in and outputs. This reference kit is provided free of charge for a certain period and is considered as a development sample. Furthermore, openDAQ will run sessions or webinars to learn more about openDAQ and how you can use the SDK. But did I miss something important? Yes, I did. Jure already mentioned that openDAQ will go open source. For this, we are already launching a partner program helping us to bring the openDAQ source code into shape in a state that developers like to work with and contribute to. The target is to launch openDAQ as open source on GitHub at the Automotive Testing Expo hosted in Detroit in October. From then on, openDAQ will manage the community and drive the open source projects so that the next release will come soon and more devices will be accessible. Last but not least, we are building up an interoperability lab to ensure the quality of the SDK with devices from supported vendors, for example HBK and Devasoft. If other vendors want to state that their device works without issues with the openDAQ SDK, they can test the device in the compliance lab. If the device passes the test, it gets the openDAQ compliant mark. Now let's have a closer look over the technologies and specifications that the SDK is built on. openDAQ relies on 3 specifications for discovery, configuration and streaming. All these specifications are based on a common and standard technologies. For discovery, we are using Bonjour, which uses MDNS for announcing services in the network. This enables the SDK to easily find all devices in the network. OPCUA is used for configuration and data can be streamed via a variety of technologies, WebSockets, TCP/IP or via OPCUA, which also use TCP/IP as a network protocol. So an Ethernet connection is set as a standard physical interface. But this doesn't go far enough. So specifications also define how packages for streaming are defined on the wire, how the object or information model looks on OPCUA, and which information is available via Bonjour. The object model is defined in such a way that variables are self-explanatory. For example, offline configurations are possible and rich, intuitive user interface can be built up on them. The streaming protocol is defined in such a way that synchronized data with high sample rates can be streamed reliable. So depending on the system where the SDK is running, several mega samples are no problem. For more details, you will find these 3 specifications on docs.opendaq.net. One for discovery, one for the OPCUA, and one for streaming. A last note before I talk about becoming a selected partner. For the OPCUA object model especially, we know that there are working groups from the OPCUA Foundation working to define new standards. For the moment, we have driven a vendor-specific specification to enable a fast release. However, the joint venture is already a corporate member of the OPCUA Foundation and we are also ready to go with you, the openDAQ community, to convert our vendor specification into a companion specification approved by the OPCUA Foundation after the release in June. So now, let us talk. How can you become a selected partner? First, if you have any questions about openDAQ, please feel free to contact us via openDAQ@blueberryduck.com. But for accessing the pre-release, you have 2 options. The first option is to contact the JV shareholders, HBK or Devasoft. This is especially emphasized if you already have business relationship to one of the shareholders. They can tell you directly how to use the openDAQ with their products. Since they also finance us, they have unlimited access and can offer support already. But as we mentioned, we want to open for everyone. So there's a second option. In case you have no existing business relationship with HBK or Devisoft. In that case, just drop us a line explaining why you should be a partner for the pre-release. We will get back to you regarding access. For everyone else, please stay tuned. June is coming soon. I'm already looking forward to seeing you face to face at the Automotive Testing Expo in Stuttgart in June. There we will also be presenting a session and we will be able to give you a detailed and exciting insights into the SDK. And with this I would like to open the Q&A.